Hi everyone, so we're going to start a new booklet today and we're going to look at the refraction of light. Now you've done a little bit of revision on National 5 refraction, but we're going to go into more details and we're going to come across some equations that we haven't used yet. So you know that there's an angle of incidence and an angle of refraction when something refracts, and something refracts when the light or whatever it is that is refracting changes speed when it goes into another material. So, for example, from air into glass or from air into water. And usually when it goes from air into glass, it bends towards the normal. When it goes from glass into air, it bends away from the normal. So you can see here that we've got quite a few new equations that we're going to come across and some definitions as well that you need to learn and just some knowledge that you need to know. So first of all, a little bit of revision. Light is part of the electromagnetic spectrum and it's the part that can be detected by our eyes, and we should all know by now that light travels at the speed of 3 times 10 to the 8 meters per second. So 186,000 miles per second in air. And obviously it travels at different speeds in different materials, but in air or in a vacuum it's 3 times 10 to the 8. The distance from the Earth to the Sun is 93 million miles, and it takes about 8 minutes for light to reach the Earth from the Sun. If we could drive to the Sun at 60 miles per hour, it would take around 177 years to get there. Light rays usually travel in straight lines, although their direction can be changed. So, just a reminder about reflection of light. With reflection, when a ray hits a mirror or a shiny surface, we have an incident ray, which is the ray that goes in to the surface. We want to draw in our normal at 90 degrees. And we would have a reflected ray. So, reflected ray. And this angle here between the normal and the incident ray is the angle of incidence. And this angle here between the normal and the reflected ray is the angle of reflection. So it says there, add a normal to the diagram. We obviously can't do the experiment ourselves, but you have done this in National 5 anyway. And the law of reflection is the angle of incidence is equal to the angle of reflection. Okay, so that's all relative, that's not new to you, that's all familiar to you, hopefully, from National 5. So refraction, so light and other forms of electromagnetic radiation do not actually require a medium to travel through. Light travels at its greatest speed in a vacuum, but the speed of light in air is pretty much the same as the speed of light in a vacuum. Light can also travel through transparent media such as glass, perspex, water, and diamond. And these media are said to be optically more dense than a vacuum. Air is only marginally more dense than space when considering its optical properties, so we pretty much think they're about the same. Refraction is the property of light which occurs when it passes from one medium to another. While in one medium the light travels in a straight line, however, a ray of light usually changes direction or refracts when the medium through which it is travelling changes. And refraction happens because the light changes speed when it changes medium. Just to note here, and this will become important later, frequency does not change. And that, as I said, will become important later on. So, obviously you can't do an experiment, but I'm going to link you to a video of this experiment, but I'm just going to talk you through it first of all. It's an experiment that you've sort of done before. You've had a look at what happens to light when you pass it through a perspex block, but you didn't really do many measurements involved in it. So what you would do is you would shine a ray box, you shine a light into a perspex block like it shows on the diagram here. The diagram has nicely drawn it in a normal for you, and this is our angle of incidence. Okay. So we'll call that, actually, we'll change that to theta 1. Okay, so the first angle. We also know that the light will be refracted, so it will bend slightly towards the normal, and we'll call the angle of refraction theta 2. So theta 1 is the angle in the first medium, which is air. Theta 2 is the angle that it refracts to in the second medium. Okay, so a ray of light from a ray box is shone into a rectangular perspex block at various angles of incidence. So that theta 1 gets changed. So you can shine it in sort of here, or you could shine it in here. So we're changing the theta 1, we're changing the angle of incidence, and we're measuring the angle of refraction at each angle of incidence. As I said, I will link you to a video of this as well. So I'm going to just give you some results from the experiment that I did, and you'll see that I have not filled in the entire table. So what I'm going to get you guys to do is watch the video of the experiment and then fill in the missing part. So you'll see that you've got to fill in this one, so sine theta 1. So the first one will be sine of 10. So if you put that into your calculator, sine of 10 is 0.17. And the other one I want you to do is sine of theta 2. So that's the sine of the angle of refraction. So sine of 7, if you put that into your calculator, is 0.12. Okay, then what you need to do is that final column I have added in is sine theta 1 over sine theta 2. So sine theta 1 divided by sine theta 2. And so that's going to be 0.17 divided by 0.12, which is 1.42. So I'm going to pause the video there, and I want you guys to then fill in the sine thetas and the sine theta 1 over sine theta 2. So I'm going to stop the video and then we'll compare our results later.